Alright guys, today we're taking a look at how to multiply polynomials of varying terms. So we already know how to multiply a monomial times anything, because that's, if you remember from yesterday, a monomial is just something that's one term. So when you're multiplying something that's one term by something that's multiple terms, that's just a distributive property. But now we're trying to look at what if you have more than one term. What if you want to do a binomial times a binomial or a binomial times a trinomial? So to help you kind of visualize what needs to happen here, I've written you an example problem that utilizes only numbers. So if we wanted to multiply 2 plus 4 times 3 plus 5, I don't actually want you to do the math. I know you could do the math. I want you to create me a problem, an area problem, that would involve you multiplying these binomials together, and then I want you to think of what would two different ways of finding that area be. Pause and then come back if you need to. So hopefully what you drew is, you drew something like this. Now, I mean, the size is not really super important here, but you maybe want to get it at least kind of close to right. So I'm imagining like a window situation where we've got one side that's 2 and 4 and one side that's 3 and 5. So the two different ways to figure out this area, obviously one would be to simply add the numbers together first, add the 3 and the 5 first, add the 2 and the 4 first, and then multiply. That would be what you'd do if you did this problem that I have up there in standard order of operations. But what you could also do is you could also do this. You could multiply the 2 times the 3 and the 5 to figure out those two small areas, and the 4 times the 3 and the 5 to figure out those two little areas, and then add them each individually up. Meaning you could do 2 times 3 plus 2 times 5 plus 4 times 3 plus 4 times 5. You could do that as well. Okay, so based on that example, how do you think you would multiply x plus y times w plus z without knowing the value of any of those variables? See if you can figure that out. What would that look like if you wanted to multiply those together without actually knowing any of the values? Pause and come back. Alright, so what you would have to do is you would have to multiply, just like up here we had to multiply the 2 times both the 3 and the 5 and the 4 times both the 3 and the 5. We would have to do the same thing here. We would have to do x times both the w and the z plus y times both the w and the z, or xw plus xz plus yw plus yz. So when we're multiplying polynomials, the rule is really simple. You take each term, and I'm going to leave this space kind of open for you to write it however you'd like, but when you're multiplying two polynomials, you basically have to multiply each term in the first polynomial times each term in the second polynomial and just add them all together. That's all we're really doing here. Okay, so the way that I typically like to set these up is I like to set it up like two distributive property problems when I'm doing a binomial times a binomial. Okay, so I often like to set it up like this. I like to say, okay, I know I'm going to have to multiply x times both the x and the 3, so I'm going to set it up to distribute the x and to distribute the 2. Then I get x squared plus 3x plus 2x plus 6. I combine my like terms, and that's what I get. Oftentimes this is called FOIL. Okay, the reason is there's a shortcut way of remembering it without having to write out this step, where you can go straight to this step. And it's by using the acronym FOIL, where F stands for first, O stands for outer, I stands for inner, and L stands for last. The whole idea is that since you have to multiply this x times both the x and the 3 and the 2 by both the x and the 3, what you're doing is you're first multiplying the first two terms. So like if I use FOIL on this one as opposed to setting it up like a distributive property problem, I could multiply the first two, x and x, and get x squared. Then the outer two terms, so x times -3. Then the inside or inner terms, 4 and x. And then the last terms, 4 and -3, which make -12. So you definitely will want to be familiar with that acronym. Again, I like to set it up like this, but it's very helpful for ones that are, you know, much easier like this, where you just have kind of x's and 3's and really easy numbers involved there, to be able to just kind of jump immediately to this step without the setup process. But I'm going to show you in the next section why I do like to show it being set up this way. So try this one on your own. Pause and then come back and I'll show you the answer. Okay, welcome back. I'm going to use FOIL on this one. So first terms are 2x times -3x, that's -6x squared. Outside terms are 2x times -5y, that's -10xy. Inner, -3y times -3x is +9xy. And I do put the x before the y, even though the y got multiplied first. And then the last terms are -3y and -5y. It's -15, or +15y squared. Combine your like terms. These two are my only like terms, and I get -1, or just -xy. And the rest all stays the same. Okay, what you're going to see in this binomial times trinomial section is why I like to set it up as a double distributive property problem. The reason is you can't FOIL this. Okay, FOIL only works for binomial times binomial. For binomial times trinomial, you just kind of have to work it out. You have to do this term times all 3 of these, and then this term times all 3 of these. Do you have to necessarily write out this step just like this, like I'm doing right now? Absolutely not. You don't. If you can do the multiplication in your head, go for it. Okay, I definitely encourage you to do that. That'll help you pick up a little bit of speed. For me, it sometimes just helps me see what I'm doing, especially when the numbers get a little bigger and more obnoxious. You may want to consider doing that. But if you can get it right without doing it that way, and you can just write out your 6 terms and then combine your like terms, that's fine. So I get x cubed minus 4x squared plus 4x. When I distribute the x, when I distribute the 2, I get 2x squared minus 8x plus 8. Combine my like terms. X cubed doesn't have any like terms. -4x squared and 2x squared make -2x squared. 4x and -8x make -4x. And the 8 doesn't have a like term either. Why don't you go ahead and try the next two on your own, pause, and then come back. Okay, welcome back. This time I am not going to show that initial setup step again, because you just really don't have to. But I'm going to be careful when I get to the -3 there. So first I get 2x cubed minus 3x squared minus 6x when I distribute my x. When I distribute my -3, I get -6x squared plus 9x plus 18. Combining my like terms, 2x cubed minus 9x squared plus 3x plus 18. I'm not going to reveal the answer to this last one because I want you to discuss that one in your groups tomorrow and just check in on everybody, make sure things went okay. Okay, last one that we're going to look at, we could do trinomial times trinomial, all sorts of other ones. I'm sure you'd be able to figure it out. But what I want to do is binomial times binomial times binomial. What you have to do here is you have to pick 2 of your binomials and multiply them first. It doesn't really matter which 2 you multiply. So if you happen to see 2 that seem like they'll be easier to multiply, go for it. Okay, I'm going to multiply here the second 2 first, because again I can multiply in any order. When I multiply those, I get x squared plus 10x plus 24. I already did all of the combining like terms there. I didn't write out plus 4x plus 6x. I combined already. If you can think of how maybe I got to that so quickly, you're probably doing pretty well. Then I've got to multiply in the x and the 3 from this one. Okay, so I get x cubed plus 10x squared plus 24x when I distribute my x, 3x squared, 30x, and 72. When I distribute my 3, I combine my like terms. X cubed plus 13x squared plus 54x plus 72. So these are obnoxious, but you can pick any two of them and multiply them first and then multiply in the third binomial. Don't try to do two of those things at once. You definitely have to do one set of the multiplication first. So why don't you go ahead and try B and C, pause, and then come back. Alright, again, I'm only going to show the answer to B because I want you to share the answer to C in your groups. Again, I chose to multiply these two first because they looked easier and I could do all of the math very, very quickly in my head. So when I multiplied those two, I got x squared plus 2x minus 8. And again, if you know how I did that so quickly, you're already in great shape. Good for you. If you had to write it all out, though, no big deal. Okay, so now I'm multiplying through my 2x. And there's what I get. Multiply through by my 3. And combine some like terms. And again, I want you to talk about C in your group. This is really where you guys have to start making sure that everybody is good to go and that everybody's staying on top of things. I apologize the video was so long in this one. I just wanted to make sure you saw at least one example of each and had a little bit of an understanding of kind of why when you're multiplying two polynomials you have to take each term in the first polynomial and multiply it by each term in the second polynomial. So hopefully that little window illustration at the beginning helped you out. That's it.